we are going to do continuity and differentiability of class 12 NCERT. So first let us do the topic continuity. So what is continuity? Continuity, by the word itself we are going to understand, which is continuity is nothing but which don't have any breaks. For example, let us take a function like y is equal to x. So let us see the graph of this. So you can see that the graph is continuous. There are no breaks in the graph. So I was able to draw the graph without lifting my pen. So that this function is said to be continuous. If I take y is equal to sim x, the graph of this will be like this. So you can see there are breaks in the graph. I had to lift my pen to draw this graph. Then this function is said to be non-continuous. So in this chapter, they'll give you a function and you have to find whether it is continuous or non-continuous. So the condition for that, to find whether the function is continuous or not, is its left hand limit should be equal to its right hand limit is equal to f of a. Now what is left hand limit? You can write left hand limit as limit x tends to a negative of f of x is equal to limit x tends to a positive f of x is equal to f of a. Now what does limit x tends to a negative? Now I'll draw a number line and this is 2. Okay, this is 2. Now what is, let x be, let a be equal to 2. Now limit x tends to negative. 2 negative means x is a value where, now here x is not equal to 2. X is near to 2. Its value is something near to 2. It's somewhere here. It's approaching, its x approaches or x tends to 2 means its value is approaching to 2. Means you can think x value is something 1.9999. Means this is very much near to 2. But this is not 2. Okay, so this is called left hand limit. Now what is right hand limit? Now if I take limit x tends to positive, its value is approaching this way. Its value is somewhere here. Means you can think 2.0001. Its value is very much near to 2, but it's not equal to 2. Then that is said to be right hand limit. So if a function should be, to know whether a function is continuous or not, its left hand limit should be equal to right hand limit, which is equal to f of a. Okay, now let's move on to the exercise. So let's see the first question. Exercise 5.1. First question is f of x is equal to 5x minus 3. And you have to check it is continuous or not in the points x is equal to 0 and x is equal to minus 3 and at x is equal to 5. So at these points we should find whether the function is continuous or not. So first let us take x is equal to 0. Now first, as I told you, you have to check its left hand limit. What is the value of its left hand limit? Now limit x tends to 0 minus f of, now f of x is nothing but 5x minus 3. Now x plus h is equal to, let x plus h is equal to 0. So x is approaching value, means which is not equal to 0. What its value is very much equal to 0, means which is very near to 0. And h is a value which when you add to x that becomes equal to 0. So the value of h is very small. Now take h to the other side, then it will be x is equal to 0 minus h. Now limit h tends to 0 f of x. Okay. So what is f of x? 5x minus 3. So 5 limit h tends to 0, 5. Instead of x, put 0 minus h minus 3. As the value of h is tending to 0, then instead of h you put 0. So 5, 0 minus 0 minus 3. So 5 into 0 is 0 and minus 3. So left hand limit, the value of left hand limit is 0. Is 3, minus 3. So now let's check the right hand limit. F of x limit 0 positive. Okay. Now take x minus h is equal to 0. Now why x minus h? Now x is limit f of x is x tends to 0 positive. Now x value is greater than 0, means it's very much little bit greater than 0. So when you subtract a value from x, then it will be equal to 0. Okay, now x will be equal to 0 plus h. So now limit h tends to 0 of f of x is equal to limit h tends to 0 5x minus 3. Instead of x we put 0 plus h. Okay, then 5 into h is tending to 0, so you put value of h as 0. 0 plus 0 minus 3. So this 5 into 0 is 0 and this becomes minus 3. Okay, now the third condition we have to find f of 0. What is f of 0? Instead of x you put 0. 5 into 0 minus 3, which is equal to minus 3. So as you see here, its left hand limit is equal to its right hand limit, which is equal to f of 0, which is nothing but, by this you can conclude that f of x is equal to x, 5x minus 3 is continuous at x is equal to 0. Now let's check its continuity at x is equal to minus 3. Now its left hand limit so x is minus 3 minus, which will be equal to, now take x is equal to minus 3 minus h. Okay, and h will be tending to 0. Limit h tend to 0 f of 5x minus 3, which is equal to 5, and x is 3 minus h. Minus 3. Now as the value of h is 0, 5 minus 3 minus 0 minus 3. 5 into minus 3 is nothing but minus 15 and minus 3. Its value is minus 18. Now let's check its right hand limit. Limit x tends to minus 3 positive f of x. Here the value of x is equal to minus 3 plus h, and h is tending to 0. So limit h tends to 0 f of 5x minus 3. Instead of x you put as minus 3 minus h. minus 3 plus h. So 5 as a value of h is 0, and h value is tending to 0. In place of h you put it as 0. So 5 into minus 3 is minus 15 and minus 3. It's minus 18. Now let's check the value of f of minus 3. What is f of minus 3? 5 into minus 3 minus 3. 5 into minus 3 is minus 15 and minus 3, which is equal to minus 18. So here we found that its left hand limit is equal to its right hand limit, which is equal to f of minus 3. Hence, it is continuous at fx is equal to minus 3. Now, let's check its continuity at x is equal to 5. Now, take limit x tends to... Now, let's take its left hand limit. X tends to 5 minus of f of x. Now the value of x will be equal to 5 minus h. And the h will be tending to 0. Okay, then limit h tends to 0 f of 5x minus 3, which is equal to limit h tends to 0 5. The value of x is 5 minus h minus 3. As value of h is tending to 0, 5 into 5 minus 0 minus 3, which is equal to 5 into 5 is 25 minus 3, which is 22. So let's check its right hand limit. Limit x tends to 5 positive. The value of x is here 5 plus h, and h is tending to 0. So limit h tends to 0 f of x, which is equal to limit h tends to 0 f of 5 into x value is 5 plus h minus 3. Now h is tending to 0, so the value of h is 0. 5 into 5 plus 0 minus 3. 5 is 25. Minus 3 is 22. Now let's check its value of f of 5, which is 5 into 5 minus 3, which is 22. As you observe, its left hand limit, right hand limit, and its value at f of 5 is same. So the function is continuous at x is equal to 5. The question is, examine the continuity of the function at f of x is equal to 2x square minus 1 at x is equal to 0. Means we have to check its continuity at x is equal to 3. So as we know the condition that to find whether the function is continuous or not, we have to find its left hand limit should be equal to its right hand limit, which should be equal to f of a. Now first let us check its left hand limit. Let limit x tends to 3 minus of f of x. Okay, and let x be equal to 3 minus h, and let h tends to 0. Then limit h tends to 0 f of x, which is equal to limit h tends to 0 to x square minus 1. Now limit h tends to 0. Now x value, we have taken x value as 3 minus h. So f of 2 into 3 minus h whole square minus 1. As h value is approaching to 0, h will become 0. So 2 into 3 minus 0 whole square minus 1. 3 minus 0 whole square is nothing but 9. 9 2s are 18. 18 minus 1 is 17. Okay, now let's check its right hand limit. Take limit x tends to 3 positive of f of x. Take x value as 3 plus h, and h is taking to 0. Then limit h tends to 0 f of 2 into we took x value as 3 plus h. So 3 plus h whole square minus 1. As value of h is approaching to 0, h becomes 0, which is equal to 2 into 3 plus 0 whole square minus 1. So 3 whole square is 9, 9 into 2 is 18, 18 minus 1 is 17. Now we will check the value of f of 3, which is equal to f of 3 means instead of x you put the value of 3. So 2 into 3 whole square minus 1, which is nothing but 18. 3 whole square is 9, 9 into 2 is 18, 18 minus 1 is 17. So it's proved. Its left hand limit which is 17, right hand limit is 17, and f of a means f of 3 is also 17. So this condition is satisfied. Hence this function f of x is continuous at x is equal to 3. Now let's move on to the third question. The question we have to examine whether the function is continuous or not. They didn't give us any points to find whether it is continuous at that particular point. Okay, now we have let's do a. F of x is equal to x minus 5. You can see that x minus 5 is a polynomial. As you observe, every polynomial is continuous at every point. So f of x is continuous because f of x is continuous at every point because it is a polynomial. Okay, so as f of x is equal to x minus 5, x minus 5 is nothing but polynomial. Polynomial is continuous at every point. When you draw a graph for any polynomial, you'll get a straight line, which you are able to draw the graph without lifting your pen. Okay, so it will be continuous. So let's see B. B f of x is equal to 1 by x minus 5. It's a quotient function. Quotient function, now you see the denominator, it is x minus 5. If the value of x is equal to 5, then what does it happen? It will be 1 by 5 minus 5, which is equal to 1 by 0. 1 by 0 is undefined. So it is continuous at every point except where the value of x is equal to 5. So except x is equal to 5, if you put any other value, this function will be continuous. Except where x is equal to 5, it will not be continuous. So you write as f of x is continuous at every point. F of x is continuous at every point except where f of x where x is equal to 5. Because when x is equal to 5, it's becoming undefined. So the function becomes undefined where x is equal to 5. So f of x is continuous at every point except where x is equal to 5. Now you put in the place of x any other value except 5, the function will be continuous. But if it is 5, it will become undefined. So f of x is continuous at every point except where x is equal to 0. X is equal to 5. Now let's do the C. F of x is equal to x square minus 25 by x plus 5. Now, this is in the form of a square minus b square, which we can write it as a minus b into a plus b, right? This is in that form, a square minus b square. So we can write it as a minus b into a plus b. Now, f of x is equal to x minus 5 into x plus 5. Okay, I wrote it in this form. By x plus 5. X plus 5 gets cancelled. You get f of x is equal to x minus 5. Again, x minus 5 is a polynomial function. As I told you in this question A, that a polynomial function is continuous at every point, because when you draw its graph, when you draw the graph of a polynomial function, you will get a straight line. So which you can draw without lifting your amendments, which is continuous. So f of x is continuous at every point. At every point, because it is a polynomial function. So let's see the question D. F of x is equal to mod of x minus 5. You don't see it's a mod. So now let us write that it is in mod. You can write this as, now you think if x value is greater than or equal to 5, then it will be x minus 5. If the value of x is less than 5, then it will be 5 minus xy. Why is it like this? As it is in mod, whatever the answer comes out should be in positive. Now if the value of x is greater than 5, then x minus 5 will be positive, because the value of x is greater and the value of 5 is less. Then when you subtract, you will get a positive answer. Now if the value of x is less than 5, then the value of 5 is more. So when you subtract 5 from x, when you do 5 minus x, you'll get a positive answer, right? So we have to write it in this way, 5 minus x, because here mod is given. Now we will check its left hand limit. Limit x tends to 5 minus of 5 f of x. Now it is x tends to 5 minus, means it's left hand limit. The value of x is less than 5. Means it's very much equal to 5, but it's little bit less than 5. So when the value of x is less than 5, see here, x is less than 5, then the value is 5 minus x. 5 limit x tends to 5 minus f of 5 minus x. As x's value is approaching to 5, we write this as 5 minus 5 is equal to 0. So its left hand limit value is 0. Now we'll check its right hand limit value. Limit x tends to 5 positive f of x. Now the value of x is little bit less, more than 5, a little bit. So x is greater than 5. When x is greater than 5, it is x minus 5. So limit x tends to 5 positive f of x minus 5. As the value of x is approaching to 5, x will become 5. So it is 5 minus 5 is equal to 0. Now we will check the value of f of 5. F of 5 is equal to mod of 5 minus 5, which is equal to mod 0, which is equal to 0. So as you can observe, its left hand limit is equal to right hand limit, which is equal to f of 5. So LHL is equal to RHL, which is equal to f of 5. So this is a continuous function. F of x is continuous at every point. We have to prove the function f of x is equal to x to the power n is continuous at x is equal to n, and where n is a positive integer. As we know, to prove any function is continuous or not, we have to show that its left hand limit should be equal to its right hand limit, which should be equal to f of a. Here we have to show it as f of n. Okay, now first let us find its left hand limit. Okay, left hand limit, then you write limit x tends to n minus f of x. Take x value as n minus h, where h tends to 0. Okay, then limit h tends to 0 f of x to the power n, which is equal to limit h tends to 0 f of, as we told you, x is x as n minus h. N minus h to the whole power n. Now as h value is tending to 0, h becomes 0. Then n minus 0 whole to the power n is n to the power n. So its left hand limit is n to the power n. Now let us find its right hand limit. Now limit x tends to n positive f of x to the power n. Now take x value as n plus h, and the value of h is tending to 0. Now limit h tends to 0 f of x to the power n. As the value of x is n plus h, we write limit h tends to 0 n plus h whole to the power n. As h is tending to 0, h becomes 0 and be n plus 0 whole to the power n, which is n to the power n. So its right hand limit is also n to the power n. Now let us check what is the value of f of n. This is n. Okay, now in place of x we have to put n, right? So n to the, in place of x we are putting n, and it's n to the power n. You see its left hand limit, right hand limit, and f of n is equal. So this function is continuous. We have proved this function as continuous.